Hi everybody, welcome to my channel. In this video, we'll be talking about micro nuclear reactors. This is different from small modular nuclear reactors. Please remember to like and subscribe. Now let's get right into it. Fact 1, up to 20 megawatts. Micro nuclear reactors are very tiny, and their power output is extremely small. In fact, if you think about it, the large-scale traditional conventional nuclear reactors, such as the one you see here with two large cooling towers, they generate hundreds if not gigawatts of power. But for a micro nuclear reactor, that is not the case. Micro nuclear reactors are very small, and its miniature version creates really only 1 to 20 megawatts at most. This means that they're not designed to power a whole city grid or replace any sort of power plants. They're really for very localized usage. And you should think about them as like a diesel generator that you would put on the back of a truck and haul to a remote location so that you can have power there. That's what micro nuclear reactors are designed for. It is a whole new way to think about nuclear power. Alright, let's get into the next fact. Fact 2, just for heat. Now, when you think about nuclear power plants, they use the heat generated from the nuclear reaction to boil water to create steam, which then drives the turbines. But micronuclear reactors, on the other hand, may not need any of the electrical generation components, the turbine, the water, the steam. What people are envisioning micronuclear reactors to do is to really provide heat directly. This means that using a nuclear reactor as a heat source, and not as a power source. So you can imagine your traditional fireplace or furnace at home could be replaced by a micronuclear reactor, and it generates heat through the nuclear reaction, and you use this heat to heat up the home for temperature control, not necessarily for power. It is a very unique way to think about nuclear power. And if you think about it, using nuclear reactors to provide a heating source will be very clean and efficient, and there will be no worries about smoke or carbon monoxide or carbon dioxide from a traditional furnace. Cool. Let's get into the next fact. Fact 3, enriched uranium-235. One of the issues with using micronuclear reactors is that it requires highly enriched uranium. The uranium-235 is a weapons-grade uranium used for the first nuclear bombs that were dropped in Hiroshima and Nagasaki in Japan during World War II. These bombs, early bombs, used the exact same fission material, the enriched uranium-235. And so, for micronuclear reactors to work, they need weapons-grade enriched uranium. And this is a problem because currently no commercial use is allowed. And because of the fear of losing this enriched fuel to create bombs from terrorist states or rogue countries, this is going to be a problem for the Nuclear Regulatory Agency to consider how they can allow private companies to use this highly regulated fuel source, not to create bombs, but to power micronuclear reactors that people could put in many locations. Alright, that's the next fact. Passive safety. Passive safety in micronuclear reactors is a key feature of it. If you think about it, nuclear reactors probably scares people and requires a lot of specialized equipment and specialized knowledge to use them. For micronuclear reactors, they're trying to change this concept. They want to create micronuclear reactors where there's simple on and off buttons and emergency shut-off buttons so that people do not need specialized knowledge to operate them. Imagine a group of people putting a micronuclear reactor on a truck bed and then hauling it to a specific remote location where they can just press a few buttons and start using their nuclear reactors. And with passive safety features, if the nuclear reaction is unstable or out of control or something is wrong with the reactor, it will simply shut itself down. And therefore, prevent any sort of catastrophe or meltdown with a reactor, and people could use it without any specialized knowledge or skill set and be able to harness the power of nuclear reactors very safely. Alright, let's get into the next and final fact. Fact 5. Use and replace. Another different concept of micronuclear reactors is that it is replaceable. The people behind this technology envision that you would simply put a microreactor to where you need to use it, and once the fuel is spent in the reactor, they will simply return it back to the manufacturer and get a new one. That way, there's no need to manually handle any radioactive materials or to take apart the reactor for service. It's a very new way to think about nuclear power, and perhaps in the future, this will be possible. But as of now, the technology is still 10 to 20 years away, and for people to be accepting nuclear power in this fashion is still a very long ways to go. Alright, that's it for my video today. Thank you so much for watching. Please remember to like and subscribe. See you next time.